We're going to look at ways of converting an image over to a vector file. You can do some of this in SolidWorks. I've never used the auto tracing tool in SolidWorks, but there is an auto tracing tool. You can also just import an image into SolidWorks, zoom in really close, and use the spline tool. I've done that plenty of times for parts that aren't very complicated, something like the state of Ohio. I can outline it in about 30 seconds if I just zoom in really close. The advantage of using SolidWorks is most of you are more comfortable with SolidWorks, and you can edit the nodes very easy in SolidWorks. When we get into using PhotoLaser, if at any point in time you need to edit the node, which means to correct the vector's path, you probably should just work in SolidWorks, because using the node editing software is very finicky in PhotoLaser. So the first thing I'll do is I'm going to import my image. This is the original file. I'll talk about this JPEG later. And I'm going to shrink this back down to 4 inches just for working with it right now. No real particular reason. With a high quality image like this, you can actually convert it over to a vector file very quickly. If I just click on Transform, Render to Bitmap, and then Monochromatic. This will take literally every color it sees and make it either black or white. So once I have converted over to black and white, I can then just double click on the image, and then I can click Vectorize or Vectorization, and it should take just a few seconds as soon as I hit close. And that's done nearly instantly. And you can zoom in and you can see that the contours are pretty clean. There's not lots of weird jerking motions going on, so everything looks fairly good. And I could go ahead and use this. This is not a bad copy of this. Some of the corners aren't as sharp as they would be on the actual CAD file, and then there's some oddities like this. Maybe I could run it 2 or 3 times. I could have it at a different zoom level. That could have some effect. But this might be a problem when lasering it, but for the most part, that takes about 10 seconds to do. Everything after this is kind of labor intensive. Later on in the video, I'm also going to show you how to edit the file itself, but for now we're going to stick with methods of converting an image over to a vector. I'll just go ahead and leave it large this time. The tool that is built into PhotoLaser or EngraveLab, whatever we want to call it, to convert the image over is in the Image tab, Prepare to Vectorize. This can take quite a while sometimes, and I've had mixed results. I've had it turn out worse in some cases than just doing the quick method. And you can see here before I keep going, this is a watermark that's behind it, and I'll talk about that in a minute. So I've had the Prepare to Vectorize wizard work out worse than it does just by using the straight bitmap conversion. This also takes a little bit of time. Sometimes it takes 2 or 3 minutes, other times it's pretty quick. So the first layer is done. It's asking me if I want these colors to be converted in this way. So in this case I do have this beige field that's being converted to white. In this case I agree with that. So now I have the first layer is done. Once it's prepared the image in black and white for me, I'm going to again do the same thing, double click, and then click on the vectorization tool. You can also reach the vectorization tool from over here. So you have scan tools. Got to close this first. And then it opens up the same toolbar, so double clicking is usually faster. And then once I click close, I can move the image away from the vectored image. So again, as you can see, this does have a watermark. There are a few ways to get rid of the watermark. Doing it this way with this particular image and how close the watermark is, if you zoom in, you'll see that it causes some artifacting around the edge of the logo here, so it kind of messes with the logo. So we can clean off that watermark beforehand. We can also clean it off right here. I'll show that first. So if I have my image, I'm just going to highlight everything. I'm going to arrange. Going to layout, ungroup all. That's going to ungroup all the individual paths, and then I can just click through here and delete all of these, and you can see some of them are in large chunks. There's also a little relic right there. Other bits are in little small pieces, so it's easier just to window it open, and you can easily step through and delete all of these. Another approach to to getting rid of the watermark. In this case, I just saved it as a JPEG, and then when I bring this in, there's no longer watermarks behind it. So you can see here, it got rid of the watermarks for me. The JPEG doesn't carry the watermark data, so it just drops it off from the file. So an odd thing that happens when you convert it to a JPEG, sometimes you'll get this frame around the outside. Again, the same as last time. I'll highlight everything, layout, ungroup all, and then I can just delete it in one go. It's also a good idea to regroup it. Group. That way when you select on this, it picks the entire feature versus picking just one line group. There are a few other approaches. Oops. Image, file, import, the original here. I can import this, and one of the things you can do is just crop it. Double click on the image. Here's the crop tool right here. All you need to do is highlight. This is going to be tedious. Let's keep going. So right around the edge here. So now I have it right around the profile of the part, and then I just click the crop button, and that gets rid of the area outside. Again, it's going to create that weird frame. So you can see this time, again, I get that weird frame that happens on the outside. All you have to do is go to Layout, Ungroup All, and then just remove that frame. And then I did get some portion of the box is left on there. That just happens. Layout, group. Now everything's grouped together, and we can zoom in on problem spots like this, and you can see it kind of cleaned that up when I did it this time. There are multiple ways. The other day when I was practicing, I did 3 or 4 different ways, and I've forgotten one of them where I removed it away. One thing you can do, which doesn't always work, if I bring in the image again, if you just convert this directly to a bitmap and you do the monochromatic, what it will do is take all of these lines right here and it just blocks them all off, and sometimes that leads to a very poor vectorization. So you can't always use this tool. It only works in this case because it's very clean. Sometimes if you use this tool and then you use the vectorize, prepare to vectorize tool, that can also have negative effects. So you have to play around a few ways. There are 5 or 6 different ways to convert these over. Again, the quickest is just to do the monochromatic if that works. If that doesn't work, the next thing I would try is image, prepare to vectorize. If that doesn't work, I would go to SolidWorks and either A, trace it by hand, which is much quicker than it sounds, or B, use the SolidWorks auto tracing tool. I've never used it. I've heard it works pretty well. Now that we have our vector file prepared, we can go ahead and start processing it and have it engrave or cut however we want it to do. One note on this file I have here, I don't think this is one of the official files. I think this is something I've made in the past, but we can get the official files from OU for Cutler Hall and the Bobcat Attack Cat. So you can get the actual AI or DXF files from them directly. In this, when I import it, it comes in with 3 layers, and that there's some base layer that's not doing anything, and then there's the red and the black layer. I'm just going to convert all of these to a single layer, so collapse all layers. Once I've done that, I'm going to change everything to a single color. Now as it sits here, if I just click to show fill, if I unshow the fill, and I send this to the printer, it'll do a cut, so it'll just cut around the part itself, and I don't need to do anything else. So if I just want this to send to the printer and cut an outline, all I have to do is have it unchecked to show fill, and it will directly cut. If I want to have it raster or have the fill sent to the printer, again, all I'm going to do is just show fill. As you can see here, I will have to change some of these to where that they aren't filled in. So all I'm going to do is just click on these items and just click the transparent layer here. And then I happen to know in this case that I can highlight, oops, I can highlight most of this and capture these items and change them all at once. So now if I wanted to send this to the printer and I wanted these portions to be filled in, all I have to do is change all the colors that want filled in to the black layer, and then all the colors I don't want to cut or don't want to engrave to the clear layer, the white layer, and just hit send to the printer, same as I did before. Now if I want to start engraving and cutting different portions, that's a little more drawn out, but from here on out I'll keep everything with the show fill active, and then I'll select the features that I want to have filled in and go from there. To quickly show you the options I can do, I'll just open a new file real fast and then I'll come back to this one. So here I've made a grid of different versions I could print. This is the pure vector version, which will just cut, and this is the version that will raster. I mean, this one obviously isn't very good because I left these all filled in. So this would be the processed versions of this right here. The other versions I tried with different colors, so you can have it engrave it one time and then it'll make some portions lighter and some portions darker, so you can step through and do pretty much whatever you want when you're using the vector file. So again, this would be the standard version that you would do if you just did the engraving off an image, except that it would be significantly sharper than an image. This would be very clean lines on the outside edge. So that'd be the reason I would do all that work to process the image. The rest of these are if you want any stylistic changes. So now I'll switch back and show you how to achieve most of these. So that only took 20 or 30 seconds, and I've gotten this completely back in. I imported the EXF, I collapsed all the layers, and then I went through and made everything white and black that should be. So if I wanted to, in this case, I'll keep the text black, and I will just contour the face here. All I'm going to do is highlight the face. I need to get all the features that I want, and then I'm going to change them to another layer. I'll make them the blue layer. I'll right click and just have it contour. So now the letters will be filled in and the bobcat face itself will be cut. Something that's kind of an odd thing you should do is keep everything in the same color and the same layer. It sounds kind of fiddly for workflow, but if you don't do this, sometimes you'll end up getting weird artifacting when you're laser cutting. It'll cut in an odd sequence, or it'll do the same layer 2 or 3 times that you're not anticipating. So if you make everything same color, same layer, it gets rid of a lot of problems. So now you can see I did that. If I wanted to make this nose portion filled in, if I click to turn that off, it actually just inverts everything. So this is a bit of an oddity with this program. I got to click back on here. So flip it back, it just inverts everything again. So all I have to do is change this to another color, and then again, bit weird, turn off the contour for this version. It'll fill it in blue. Now that it's filled in blue, I can change it back to black, and now I can have different portions filled in if I want. Again, this is a bit tedious, but you can work around and get all the different parts that you want filled in the color that you want them to be. And this, what I'm doing now, would be kind of a strange look, but we'll go ahead and do it. So it's a bit fiddly. You've only got to do it one time, so it's not that big of a deal. Oops, oh well. I'll change all these back over to black. So now I've got this entire section here will be filled in, and then the other portions will be back to being cut. When you switch back and forth a lot, sometimes you end up with layers underneath, and you might have it raster a section and then come back through and engrave or cut that section. So you want to make sure everything's in the same layer. If you're sending it to the machine and you end up seeing that it's going to raster an area and then it comes back and then it vector and cuts it, that's just wasted time. So you need to readjust your file to get rid of it. Sometimes it's easier just to restart. I know you hate to hear that, but it really only takes a minute or two to bring a file back in and quickly process it and make sure you do it cleanly so there are no weird artifacts. Having it cut parts 2 or 3 times just wastes time in the end. I'm going to quickly show you some key information from the user manual on getting your cut times down. The user manual is located right below the computer monitor here. It's got lots of decent information in it about how you can use the laser and how you can set up your cuts effectively. But there is a few pieces of information in the quick start guide. So in the book, it's flagged on page 75. You can see here what it's telling us is that if you cut horizontally, it's usually faster. So for a continuous image, such as what's shown here, there's continuous graphics being cut the entire time. If you just rotate it horizontally, you get about a 20% savings on time, or 34% it says more specifically. So if it's a continuously engraved item, horizontally is typically better. It's going to step down less times. The step over is kind of the slower thing. And again, the higher the DPI, the greater this is going to be exaggerated. So typically horizontal is faster. However, if there are large breaks in the graphic here, so there's a break here, the machine automatically knows not to cover a section where there's nothing to be engraved, so it's going to skip this block, it'll skip a thin block right here, it'll skip a thin block right here. In this case, it's actually better to have it vertical because it's only going to be engraving this short section here, this logo here, this section, and then this other section. So it's going to break it up into 4 chunks, and it's going to rapid travel between those bricks. Whereas this, it has to travel horizontally the entire way. So there is no one-size-fits-all answer. It's definitely worth the time to try 2 or 3 arrangements, and you can dramatically cut down the time. So if it's continuous, typically horizontal is better. If there are large breaks, you might get away with doing vertical as being faster. And then there is one final section on page 96. There is a third way we can send things to the printer. We can break them into chunks by color, and the color will just tell them to print that entire color before another color. It has nothing to do with the color that the part is going to be. So in this case, instead of the printer running across this entire row and then down across the entire row, it's going to instead do all the red, so it's going to have a very short travel, and then it's going to do all the green, and then all of the blue. So I could have turned this vertical, and it would have done a similar thing, but I can have it set up horizontally and break items into colors. The reason I'm highlighting this, in the past we had a team do a foosball table, and if they had broken it up into colors, they could have done the vertical bars on both of the ends over the 2 foot of the part. So if you imagine this being a 3 or 4 foot long by 2 foot item, if they wanted to engrave a bar on the end on here and over here, they could have had, and the circle in the center. If they had done that in 3 separate colors, it probably would have printed in 2 or 3 minutes each, maybe 8 or 9 minutes for the entire part. But instead they had it set up with one giant file, and the laser would fire over here, travel 2 or 3 feet, and fire over here and step down. And it was going back and forth, and it took over an hour to engrave. And then it had to, again, so it'd fire over here, it'd hit part of the circle and fire, and then travel all the way here and fire again. So there's lots of dead travel time. If you can break it up, you can do it by colors, and it should decrease your travel time or decrease your total cut time. Something I will point out, I'm not going to cover in any great detail, is doing a photo or something that has gradations rather than just white and black. I don't suggest trying that. To my knowledge, I've never seen a team try to do anything with a gradient. Most teams just do straight black and white. But you can see here there's even a warning that you really shouldn't do this with the software provided. You really need a third-party software. I've tried several times. I've tried different dithering approaches here. It is difficult to get parts to show up well on wood. There are examples. We have some examples in some of the labs of parts that have been cut or photos that have been cut. But typically it works better on a uniform material such as MDF or hardboard and other materials like plastics and glass. But on wood itself, it's not very good. It's also very difficult and tedious to set these up. Even if you're working on a uniform material, you might have to go through 8 or 9 different versions to see if it works. So I do not encourage you to use any sort of photo or gradiated parts that you're going to engrave on your workpieces. Here's an illustration of what increasing the DPI actually does. You can see here, basically the laser is just going to fire more times per inch. So it's going to fire twice as many times in the same period. That will cause it to burn more. It also, as you can see, causes it to step down each row more frequently. So 300 DPI, it would only take 3 lines to get this done. 600 DPI, it's going to take 6 lines to get this section it's showing being done. So increasing the DPI has a big impact on time because of the number of lines it's going to take.